W is the midpoint of Vx. W is the midpoint of Vx. I'm going to give you a huge leap on how to do proofs right now. W is the midpoint of Vx. I would stop reading right there. I would do two things. I would, A, we know midpoint allows me to put marks on it. So that's the first thing I'm going to do. The first thing I'm going to do is make sure my head's up. Then the second thing I'm going to do, I'm going to put marks on there. What marks can I put if something is a midpoint? We're going to put our tick marks. And we just have to locate where W is. So I'm going to go, oh, it's a midpoint. Boop. So I'm going to put tick marks on either side. So it's of Vx, tick mark, boom. Here's the next thing I'm going to do. I'm not even going to read the rest of it. I want this to be a knee-jerk reaction for you. Midpoint is a fancy word. It's a fancy word we learned in geometry. That means you need to explain it to the person that you're displaying this proof to. You have to tell them, hey, I know what a midpoint is. So I'm going to go down here and I'm going to write that given down first before I even look at anything else. So I have W is the midpoint of Vx. I'm all terrible. What's the reason for that? Given. Thank you. Thank you, one person that knew that was the given. Given is always your first step. If you get that wrong on the test, I don't know what I'm doing. You better get that given right. Okay. Now, have I looked at the proof at all yet? No. What I want you to know is when you have a fancy word, I'm going to use a word called unpack. Unpack what that means. When I use the word unpack, I'm generally meaning define what it means. Most of your unpacking happens in your definition. That means we should probably have our packets out and look for the definition of midpoint. That's what I'm going to be when I unpack something. Unpack, I'm looking for the definition. Patrick.
Point that divides a segment into two segments.
A point that divides a segment into two congruent segments. That's what we drew, right? We drew a point dividing a segment into two congruent segments. We need to write that here. We're not going to write the definition. We're going to say how it makes our life easier. It makes our life easier because now we know that VW equals WX. It equals them. That's what we can then write on there. Are we clear on that? Okay, so that's the first thing I'm going to do. I'm going to go ahead. I wrote the tick marks. My first step is to say what it means. So I'm going to put VW equals WX.
Does it matter if you use the congruent symbol?
It does a little bit. It does a little bit. Can we do it this way? I'm actually shortening this proof. Let's do it with the congruent symbols afterwards to see how it would change. Patrick asked a great question because the definition technically says congruent, so I should use the congruent symbol. I was trying to keep it easy for your first proof, but bear with me, I'm just putting an equal sign. I actually skipped a step. Okay, let's keep a pin in this. I actually skipped a step. All right, but right now I have VW equals WX. And that's because Patrick just read it out of the book. He read the definition of a midpoint. I'm telling you right now, if you know that one step, that when I say a word, you define what it means, proofs become a lot easier. If you don't know to do that, it makes your life a little tougher. So, unpack a word, that's my first step. I unpacked it, now let's look at what we actually have to do. I also have another given, xy equals vw. We'll hold on to that for a second, put it in our pocket. Well, maybe I'll mark it on here. So we have xy is congruent to vw. xy, maybe I'll come up with a new... Actually, I don't need that one because we have xy is congruent to vw. So I'll redraw this. We have y, we have vw. I'm going to put my double tick marks on here. That's my next given. I need to prove that wx is equal to xy. That should have a congruent symbol on it. I need a congruent symbol right there because I did put those lines above it. That does need a congruent symbol. I didn't see a whole bunch of people write that. It needs to be written down there. This needs to be a congruent symbol. Example 1, this needs to be a congruent symbol. Okay. Marco, did you have a question? The first one would not need one because it doesn't have the lines above it. Equal sign if there's no lines above it because it means distance. Congruent symbol if you're talking about lines or angles. Okay. Not correct best time, but okay. Hey, I like to pause here and make sure the proof makes sense. I need to somehow go, okay, from the stuff that's written here to get Wx equals xy, I need to have Wx equals this xy. Did I make the march wrong? Xy. Oh, no, we're good. Is VW. Okay. So we have to get from Wx is congruent to xy. So let's go through this. Does that make sense? Let's use a quick property here. So I want to show that Wx right here, is congruent to xy. That's my goal. So my goal is to basically, let me just highlight this. I want that congruent to that. Let's just look at the marks. Yeah. You sure? I just want us to know what we're trying to prove before we try to prove it. So let's look at the tick marks here. Do I know that this is congruent to VW? Yes. Do I know that VW is congruent to WX? Do we have anything that says if this is equal to this and this is equal to this, that the first things are equal to each other? Transitive. Once again, follow my thought process here. This right here is XY, right? Do we know that's congruent to VW? Yes. It shouldn't be mind-blowing. I put marks on it. Do we know that VW is equal to WX? Yes. Did I go from XY to WX then? Yes. Yeah. I use the transitive property to go bloop, bloop, bloop. We just have to be able to write that. So let's go ahead and give that a shot. So the next thing I would do here is I'd write the given. So I'm going to put xy equals VW. And that is my given.
Why would you do that at the beginning?
Because I like to unpack this first.
Okay.
So sometimes, if the givens aren't exactly the same, I typically separate them. If they were both like congruent statement, like xy equals VW and wx equals something else, I'll usually list them together. If they're saying completely different things, like one saying is a midpoint, the other one saying things are congruent, a lot of times I'll space them apart. So I don't forget to unpack stuff. And I like to have the unpacking happen right after the given it was unpacking. I like that the step right above it is what's impacting here. Because if I put this in between, all of a sudden I lose track of where that midpoint was.
So if we were to put all givens at the
I wouldn't take any points off. Yes. All right. Can we make sure we pick up our heads? I know this is tough stuff. Guys, the more involved you are in this, the easier it's going to be in the future. The more you're just like, Mr. Pabian wrote something. Oh, got to write something. The worse this is going to be for you. We have 3 days, a review, and a test. Today's a big day for you. Okay, so we have xy equals VW. That was given to us. Now, my next thought here is just like that question that was asked, I'm going to break things apart. I'm going to kind of break things up. Actually, let's not do that. Let's do it a different way. So I now have VW equals WX, and I have VW equals XY. I ultimately want WX equals XY, right? Do I have, what I'm asking myself is WX and XY are already included in both these statements, right? Is there anything that links those two statements together? The transitive property, the VW connects them together. So just looking here, I'm like, you know what? VW and VW link these statements together. Which means by the transitive, I can write this as WX equals XY. That is going to be the transitive property. Now, a lot of us will be done here. we'll go, oh, I have wx equals xy. But Patrick brought something up. He said, what about the congruent symbol? Do you see how this has a congruent symbol? And currently I don't have that congruent symbol? My answer has to match this. My answer has to match this. So I need to now rewrite this as wx is congruent to xy. What lets me rewrite an equal sign with a congruent sign, Michael? Not the reflexive property. Reflexive property lets me rotate them. So I get what you're saying. Luke?
The definition of congruence.
Definition of congruence lets you go between an equal sign and congruent sign. Which goes back to Patrick. I'm glad you pointed this out because I really skipped a step technically. I just wanted to get us into the proof before we did. There actually should have been a step here. Because what's the definition of midpoint?
That they're congruent.
That they are, does it say they're equal or does it say congruent? It says they're congruent.
Actually, ours says equal.
Yes.
Oh, it says equal. Okay, then we're good. Last year I did it as congruent. Okay, if it says they're equal, then we're good. But if it said congruent, we'd have to put the congruent symbol on there. You have to do what the definitions and postulates say. So if they say they're congruent, you put a congruent symbol. If they say they're equal, we put an equal symbol. Is that going to kill your proof? No. Am I going to be like, ha, this guy thinks he can do a proof and he ends with an equal and it should have been a congruent? You're not going to lose a ton of points at all. I'm looking for your thought process, basically. It's just if you want to get that bump from like a 9.5 out of 10 to a 10 out of 10, that's how you get that little extra boom. The way you separate the people that are actually practicing versus the people that are just rolling their heads in the back of the classroom. Okay? All right, we got a couple more proofs to get through. So let's get ready. I know it's kind of boring. We just kind of go through this stuff, but today is our long day with proofs. It's me doing stuff. Tomorrow we do the next day we do 3 proofs and the rest is on you. So bear with me right now. Bear with me. You got to understand the practice of it. All right, we have given angle PTR is congruent to angle QTS. There's no word to unpack, so I'm just going to write it down. There's nothing to unpack, so I'm just going to write down angle PTR is congruent to angle QTS. I'm terrible at this. What's the reason I can put that down? It's a given. Okay. Once again, you get that wrong on a test, I don't know what you're doing. What we need to picture is we have a big angle, PTR. PTR is congruent to QTS. QTS. I want to prove that those two little angles over here are equal to each other. That's my goal. I'm going to throw a conjecture out there. This is the exact same proof I just did, but with angles. This one was, I had a big segment and a big segment kind of equal to each other, and I just needed to subtract things away. This one, I have a big angle, and I want to subtract out that middle angle to see what's left over. These are called kind of like overlap proofs, where I'm going to say, oh, if I do this whole length, and I'll highlight what I'm talking about, I have PTR. PTR is that length there. STQ is this length here. Ultimately, and I'll put this in blue, I want to show that this angle is congruent to that angle. So my whole goal is just to chop off this middle one. Say that these two things are equal. Already got that they're equal. If I'm going to chop something off, I first have to break it into individual parts. Individual parts. Just like this one. I broke this drawing into individual kind of parts. That we have BW, see the little individual parts? I want to be able to describe this into individual angles. The only way you can do that is by adding angles together. To say, you know what, a big angle is actually comprised of little angles. So I might say something like, well, you know what? Angle PTR. And in fact, I'm going to do one thing to save us for just a second. I'm going to change this to measure of angle PTR. It's a little easier to change things into measures.
Do you need a proof for that?
We don't need a proof, we need a reason though. What lets us change something from a congruent symbol to an equal symbol? The definition of congruence. That will be the reason I can do that. Definition of congruence. Now I need to do that because the next thing I'm going to use says that you can take an angle plus another angle, it equals a bigger angle. The only thing I can add is I can add measures. So I change it to measure so I can say something like this. I can go, oh, you know what? That big angle is actually comprised of a couple smaller angles. So I'm going to say, you know what? That big angle is comprised of measure, let's do the bottom one. So do you see that angle PTQ? Do you see that little angle right here, PTQ? If I then add on to this bigger angle, let's call it RTQ. That would equal that big angle that was given there. So that would that PTR. What allows me to break an angle apart into its two smaller components? Hang on, just don't shut it out. I know we got lots of people that know it. I just want to give everyone a chance to look it up. Like Gianluca probably has his theorem sheet memorized. Once again, if you are not doing this with us, you're against yourself right now. Flynn, you think you got it? It is the angle addition postulate. No sheet needed. Crushing it. Angle addition postulate. I'm going to use the angle addition postulate again to talk about the other angle. So I want to say, you know, this angle plus the big one equals this STQ or QTS. I'm going to, when you're doing this, try to use the terminology that they have the letters in the correct order. It makes your life a little bit easier. So if I'm looking at STR, I look up here and go, oh, there's an RTS. Let's put an RTS. Let's keep it in the same order they have it. So I'm going to go measure of angle RTS plus the measure of, what's the bigger angle? What am I adding to this one? What was that? The bigger angle, what's the bigger? Not the completely big angle. I'm adding RTS to what angle? Go. STP. STQ. I'm adding to equal that. I agree that. So we're trying to make that measure of angle. You said STQ? Okay. What do I add? I have that small angle plus that medium angle. What's that medium angle? Yeah, QTR. So QTR is this one here. Okay, this is where we just have to be a little careful. So this is the angle addition postulate, right?
Yeah.
Addition.
Do we need to be writing 1, 2, 3, 4?
Yes. Yes.
So even if it's on the other side, you have to do them both?
Yep. Wait, you don't have to write them here because they're already written for you.
No, yeah.
Here we should. Because imagine we're going to get to ones that don't have the lines, where it's just a blank space for you to write. So we're prepping you to be able to just have a blank sheet of paper, and you can put a line, and you can fill these out in order. Okay, so now we have this and this. Now, I want to point out something. What do we know about PTR and STQ? Now, they're congruent. Notice how this is backwards. This is QTS and this says STQ. They're both the exact same. All that matters is the T's in the middle and we use the same letters. So that's why I said sometimes it's nice. I'm actually going to change this really quick. I'm going to change this to match what we wrote above. It's still the same angle. I'm just going to change it to QTS so you can see it a little better. So I'm going to change that one to QTS because I saw it up there. I just want to flip the letter so everything looks the exact same. In fact, do you see how this one's RTQ and this one's QTR? No, you're good. I just want us to, are we picturing this? Are we staying with me? Because this is tough stuff if you're not. These both the same angle. So if you can see they're the same angle, awesome. I'm going to rewrite one of them so they look the exact same. So I think I'm going to erase this one and call this one RTQ. Do we get the logic behind that just to keep ourselves a little neater? Okay, so I'm going to go ahead and I'm going to do that. So I'll change that one to RTQ. All right, did you guys make that change? Oh, you're just drawing. That sounds more important.
Are we able to draw like a line?
Sure. Yeah, I don't care what you put on there. So now what I'm going to say is this whole thing equals QTS, right? QTS equals PTR. PTR equals this whole thing. I have something equaling something, that's something equaling something, that's something equaling something. What property am I using next? I'm using the transitive property. And I'm using the transitive property to say, well, I want smaller angles, so I'm going to rewrite both these in terms of smaller angles, and then I'm going to put an equal sign between them. And then I'm going to look at, see how this is PTQ equals RTS? I'm going to make sure PTQ is on one side and RTS is on the other. So I'm going to pick this one to write first. So the first thing I've circled, I'm going to write first. So I'm going to write measure of angle PTQ plus measure of angle RTQ equals measure of angle RTS plus the measure of angle RTQ. And you guys already told me that's the transitive property. If only there was some way I could get rid of RTQ from both sides. Michael, do you have a question or a statement? Okay, what do you got?
So substitution would work on that?
Substitution would work there.
It would work?
Yep, transitive is just a better way to put it.
So they'd both be equally correct?
They'd both be equally, I wouldn't take any points off. I'd probably put transitive next to it because it's better. Kind of like,
Get the same amount of points?
you still get the same amount of points if that's what matters. Okay. Go back to my original premise. If there only was a way I could get rid of RTQ on both sides, I'd be done pretty much. Because I would then have PTQ is equal to RTS. Is there any way I can get rid of RTQ from both sides? Yeah, Tito. Oh, that's the same one you got last time, wasn't it? We're going to use the subtraction property of equality. It's the same thing. Subtract the measure of angle RTQ from both sides. And we're going to be left with measure of angle PTQ is equal to measure of angle RTS. And that's going to be the subtraction property of equality. Go, Flynn.
So I know we're not done. Like after that, would you just make it instead of measure of angle? Would you make it just angle continues congruent?
Perfect. So for a lot of us, this is our last step. A lot of us aren't going to get full points on this because we're like, oh, I proved they're equal. I wasn't supposed to prove they're equal. I'm supposed to prove that they are congruent. There's a difference between the word equal and congruent. So like Flynn said, I need one additional step if I want full points here. I need to turn this into just angle PTQ is congruent to angle RTS, and that would be definition of congruence.
And when we write definition of congruence, can we do like just a sign and then apostrophe s after?
Sure. I would put it as this. Definition of congruent, that's how I typically shortcut it. All right, questions on that? I'm not asking you to be able to do this proof, but do the steps I introduced to you make sense for the people that are playing along with this game? Not the people that are just sitting there like lumps. For people playing along, do the steps make sense? This is a pretty standard proof. A pretty standard proof for angles and for lines. Just picture, if you're stuck on something and you see a whole bunch of segments, just use the segment addition postulate. If you see a bunch of angles, try to use the angle addition postulate. Because proofs, most of us won't get 100% on every single proof we write. But the more stuff you give me, the more I can grade you to understand your thought process. You gotta write something. That's why people that are working with me are gonna do so much better on this stuff than people not. All right, possibly this is the last one we're going to do. I think we have slightly shorter classes, don't we? All right, guys, this is going to look more like what you're going to be expected to do in your homework. So you're not going to get any blank proofs really in your homework. We'll start having some, but this is more or less what ours is going to look like, where I have stuff that is provided for you to get the idea of stuff. So most of the time when I give you information, I skip the first step. Why do I skip the first step? It's the given. I assume that we can do that. I know assuming probably isn't the best idea, but if you can't write the given, that means you're not studying at all. I got it. Nick, I got it. Yeah. All right. Stop. Deliberate and listen. All right. See how it says midpoint? I'm not even looking at what the next step is. It's already written for us. If it says midpoint, I bet you the next step is to unpack that statement. What do I mean by unpack? Where are you looking in your packet when I say the word unpack? I'm looking at the graph or diagram so we can make our marks. And you don't have the packet yet. But if you had our packet, people with packets, which section are you looking for if I say unpack this word? Definition. You're typically looking at the definitions. So I bet you this, what was that? I have a packet you'll get. Yeah. You can use the packet on the test, so it'd probably be better to have the packet. All right, so our next step is DE equals EF. Does the definition say that they're equal to each other, the segments are equal to each other because of a midpoint? Yeah. If you're confused, look at the definition. Some of you are looking like, what are you talking about? Look at the definition of midpoint. We should probably be where I'm telling you to be in your packet. We should be in our definitions looking at midpoint. Does midpoint say it creates two congruent segments? Equal. It says equal, so we have an equal sign, right? So it says equal, so we could say DE equals EF because of the definition of midpoint. Guys, when you see midpoint, you should know the next step is definition of midpoint. When you see the word midpoint, you should go, oh, that's the definition of midpoint. All right, then the next thing says DE plus DE equals DE plus EF. Now, here's a common mistake people are going to make. You're going to go, oh, that's a segment addition postulate. Because segment addition postulate lets me take a segment, add it to another segment. But let's be clear here. On this line, does it say DE plus, is there another DE for me to connect? No. So this is a trap problem, kind of. Because we're going to say segment addition postulate, and that will be incorrect. Let's be smart about this. If you wrote segment addition postulate, you're in probably 90-some% of people that probably would have did the same thing because you immediately saw that. But what I want to point out is what changed between step 2 and step 3.
You just added the DE and EF.
I added a DE on both sides. What allows me to add the same thing to both sides? The addition POE. This actually is the addition postulate, property of equality. Go ahead.
So if there were lines over the top of them, would it be the segment addition postulate?
It could still be the segment addition postulate, but I can't. Because you can't add lines, you can add lengths.
Okay.
Because adding lines would be me physically taking a line and putting it up against each other. It doesn't give you much information except I put them next to each other. The addition postulate needs equal signs. That's why most of the time when they give me a congruent symbol, I change it to an equal sign because most of our postulates and stuff deal with equal signs. All right, now I have 2D equals DE plus EF. I'd accept two things here. Remember, this isn't in our packet. We'll see what Flynn says. Yeah?
Oh, I was talking about number 3.
Yep.
Would that be substitutions while substituting in like new...
I would accept that. I would 100%. The official one is the distributive property backwards. But we were okay, so I'm accepting a lot of different things here because we don't have it in the postulate sheet. What I was accepting is, remember how I said we could just put simplify? I added DE plus DE. Oh, up there.
Yeah.
Substitution. No, we can't. It has to be addition property of equality. So I'm going to accept simplify. A more correct thing might be collect like terms. Here's my problem with this step. Every math curriculum for geometry says something different here. Some of them just say add them together. Some say collect like terms. Some say simplify. So I just kind of accept common sense answers here. Don't make something up. Don't go as the angle addition postulate. Let me put those together. I just added two things together to make a double of those. It's like x plus x equals 2x. Questions? Okay, so we're good there. So we have 2d equals de plus ef. Now we need to get to 2de. Got it. Got it. I need that equaling just df. I don't have that yet. How do I turn segments into a bigger segment? Segment addition postulate. So I'm probably using the segment addition postulate next. Tells me that. All segment addition postulate says that, well, one length plus another length equals the big length. So let's just put down what we're supposed to do with segment addition and see how that works. So we'd have DE plus EF equals the big distance D to F. How does that help us get from 4 to 6? Mason, do you mind picking up your head? I know you're writing. I just hate heads down. It's just breeds sleeping. How does that help us? Yeah.
Because D and EF are the same one.
Are the same as?
They're equal.
Equal to what?
To each other.
They're equal to each other. So what I'm kind of looking at is, well, we have DF equals DE plus EF. DE plus EF equals 2DE. What lets us go, this equals to this equals to that, so the first two things, or the first and last thing, are equal to each other? Transitive property. By now we should understand transitive shows up a lot. That's why I always draw the picture. You can draw on these. There's no rule that says you can't draw on your proofs. I would draw all these arrows. Remember, these are, I write up here what you should probably have written down. That I can see that those things go to each other, so I can have 2DE equals 2DF because of the transitive property. And then Michael asked, can I use substitution? And you could. Questions on that? Okay, I think we could do one more. I'm trying to figure out which one I want to do. Let's do this one. We're going to do this one together because the statements are out of order. So let's get kind of our statements down first. What's my first statement? I don't care if they listed out of order next to me. You should automatically know your first statement, Will.
It's angle PQR is a right angle.
Angle PQR is a right. Oop, right has an H in it, I think, sometimes. And that's given, I hope. So I can go ahead and cross that out. I bet you that's on here somewhere. It's right there. I can cross it out. I'm done with it. If you paid attention at all what I said about the midpoint, the next step should be easy. You can actually do this without having stuff over there. Do you see that word right angle? I want to unpack what that means. If I ask you to unpack a word, where are we looking in our packets? Yeah. I'm looking for the definition. And what definition am I looking for? It's a measure it's an angle that measures 90 degrees. So I already know my second reason is definition of right angle. This is kind of the one time you're going to know your reason before you can even write it down. Because I know I need to unpack that word by using the definition. I use the definition of right angle. Now I should look for something, because I was told it equals 90 degrees. We should find something over here that says it equals 90 degrees. Do we have something that says PQR equals 90 degrees? Yes. Yeah, that's going to be my next step. The old dose is going to be measure of angle PQR. Whoop, that's a weird R. Equals 90 degrees. Cool. Did I even look what I needed to prove yet? Not really. It's kind of a reaction. I look at a word, I'm like, okay, I bet you the next step's going to be definition. And then I look at what I need to do. I need to go from this being a right angle to saying that the two things that make it up are complementary. What's the definition of complementary? that it equals 90 degrees. So I'm just trying to show that this plus this equals 90 degrees. So that's what's happening in the back of my head. I want to show that the measure of angle PQS plus the measure of angle SQR equals 90 degrees. If I can do that, I can use the definition to go backwards. So my goal is just to show they equal 90 degrees. We already have the big angle equaling 90 degrees. What can I do with a big angle to write it as smaller angles? What can I use to write a big angle that's comprised of the smaller angles? So raise your hand if you think you know. Chunky? We split it. I want to say, I basically want to say, okay, I got this big angle. I want to talk about the two angles that make it up, the smaller ones. What property, postulate, theorem, lets me go, oh, an angle plus an angle equals the bigger one? Tito? Angle addition postulate. You need to know angle addition postulate and segment addition postulate. You need to know that without looking it up. You have to just know how to add angles and segments together. At some point, you just have to know those. So I know my next one is going to be the segment, not segment, but angle addition postulate. Is there a step that says small angle plus small angle equals big angle? Do you see it? Number 1 right there. I haven't even looked at the bank yet. I'm just letting it guide me to make sure I'm doing the right thing. So I have measure of angle PQS plus measure of angle SQR equals 90 degrees. So that's gone. Not 90 degrees. I'm sorry. PQR. I jumped a step. I can't jump a step like that. I've just done this proof so many times. Okay, I don't have them equaling 90 degrees yet. But don't we know that PQ... Oh, I'm sorry, Tito. I don't want to steal your thunder.
My bad.
No, go ahead.
No, nothing.
Oh, I thought you knew what we're going to do next.
No.
Okay, does anyone know what we're going to do next? Everett? With... Rhymes with Heidi degrees. 90 degrees, yeah. No, you had it. You had the hard part. You just forgot about the 90 part. All right, yes, that's what we're going to do. We're going to take this 90 degrees, and this time it's substitution. Because I don't have something equaling something, that's thing equaling something. This is straight up substitution. I'm replacing it. Go.
On number 4, if you're going to say substitution, can you also just complementary or something like that? Or you would want substitution?
It would have to be substitution. It has to be substitution because I'm replacing it.
So couldn't you, because there's PQR in both 2 and 3, right?
There's PQR. So I have PQR equals this. So this equals PQR. This, yeah, I agree. We could use transitive there. Okay. So we can use substitution or transitive. My arm was twisted. I'll put transitive. This one is straight up coin flip of which one's better eloquent-wise. Okay, so we now have, I used this one. So my last one must be that last step that says that angle PQS and angle SQR are complementary. I'm going to use the bottom line to finish that complementary. Why? Why, if I showed they equal 90 degrees, can I then say it's complementary? Because we always have to have a reason. Definition. Thank you. Nice job. It is definition of complementary. Definitions work both ways. If you know the definition, you know how it works both ways. So this would be the definition of complementary. And I didn't even need the things off to the side. A lot of proof writing is just following a sequence of orders. They are, if you see a fancy word, unpack it. Look at this and unpack what this means. Complementary means 90. I'm looking to make things equal to 90, which means I need to break things apart. To break things apart, I need to use the segment addition and the segment on the angle addition postulate. If I need to write things in smaller pieces, we chunk it by using those two postulates. Any questions on